So we're going to do a quick review of factoring. When you have a binomial, like these three examples here, number one, you want to look for a greatest common factor. Okay, so in the first one, there's x squared minus x. So both terms have an x, so you're going to pull an x out front. And then inside the parentheses, you're going to leave what's left. So x squared leaves an x, and then you're going to keep your sign of minus and have the 1. So it's going to be x times x minus 1. With the next example, same thing, both terms have an x. So it looks going to look the exact same, except instead of a minus, you're going to have a plus. And then on the last example there, they have a perfect square minus a perfect square. There's no greatest common factor. So whenever you have a perfect square minus a perfect square, it's called difference of squares. You're going to have two parentheses. You fill the front with what you square to get the first term. So what we square to get x squared is x. You fill the back, the signs. You're going to have one positive and one negative. And you fill the back with what you square to get the last term. So we square 1 to get 1. And then lastly, how do you find the restricted values? You're going to have restricted values if you have x in the denominator. So anytime you have x in the denominator, you'll have a restricted value. You'll set those factors equal to 0. Whatever would make a factor in the denominator 0, that's going to be your restrictions. When you have a fraction where you've got values in the top and the bottom that both need to be factored, so that's the first place we're going to start. So we're going to look at the numerator and try and factor x squared minus 5x plus 4. That's a trinomial. It's going to split into two sets of parentheses. Okay, there's no number in front of your x squared, so that's always going to split into x and x. It gets a little more complicated when there's an a value in front, but right now we don't have any a values. So the next thing we look at is the signs. We've got to multiply to a positive 4 and add to a negative 5. So if you multiply to a positive, your signs have to be the same. And since we're adding to a negative, both signs are going to be negative. And then we brainstorm and think what multiplies to 4 and adds to negative 5, and that would be negative 4 and negative 1. Okay. Then we're going to look at the denominator. In the denominator, we just have a binomial, and we have a greatest common factor, so we're going to pull out our x just like we did in those previous examples. So we pull out our x, and what's left is x minus 4. So at this point, when we are simplified, we're going to take each factor in our denominator and state that it can't equal 0. So x can't equal 0, and x minus 4 can't equal 0. That one we're going to have to solve to get the x by itself, so we add the 4 to the other side, and we get x cannot equal negative 4, or not equal 4. And then lastly, we're going to go back to our fraction and simplify. Anything that is the same on the top and the bottom, we're going to cancel. So the x minus 4's cancel, and we're left with x minus 1 over x, with the restrictions that x cannot be 0 or 4. Okay, again, we're going to factor each portion, and then we'll worry about crossing out and canceling. So we're going to start with x squared minus 10x plus 9. Okay, our first term is going to be x, because that's what we multiply to get x squared. We're going to have two negative signs, because they multiply to get a positive, so they have to be the same, and they add to get a negative. And two numbers that multiply to positive 9 and add to negative 10 would be negative 9 and 1, negative 1. In the denominator of that one, we have a binomial difference of squares, a perfect square minus another perfect square. So we're going to fill the front of our parentheses with what we square to get the first term. We have one positive sign and one negative sign, and we fill the back with what we square to get the last term. Moving on to our next factor there, we've got x plus 4. There's nothing to do with that. It's just going to stay. In the denominator, we're going to factor that, fill the front with our x's. They multiply to a negative and add to a negative, so to multiply to a negative, signs have to be opposite. We need our numbers to multiply to negative 36 and add to negative 5. So since our remainder is negative 5, the bigger number is going to take the negative. So we're going to have negative 9 and positive 4. At this point, we're going to look at each of our factors in the denominator and decide what value of x would make each of them 0 to get our restrictions. So as we go across, if x plus 1 equals 0, we get -1, and so on. So we will get, going across, -1, 1, 9, and -4. That's what we cannot have. And then lastly, we're going to cancel numerators and denominators. We're left with nothing in the numerator, so we're going to use our 1 as a placeholder and over x plus 1. So our last example here is a division problem. It's a little bit different. We have to make sure that we flip our second fraction. But we'll go ahead and start with the first fraction and simplify our polynomials. So in the numerator of the first one, we're going to split it into 2 binomials. We need numbers that multiply to -28 and add to +3. So that's going to be different signs because they multiply to a negative, and we'll have +7 and -4. In the denominator, again, we're going to split it into 2 binomials. 2 numbers that multiply to +4 and add to +4 are +2 and 2. We have to pay attention to the fact that that was division, so we're going to change it to multiplication and flip our fractions. So the factors of x squared minus 5x minus 14 are going to go on top in the numerator. Okay, we need 2 numbers that multiply to -14 and add to -5, so that's +2 and -7. And then in the denominator is going to go the factors of x squared minus 49. That's a perfect square minus a perfect square, or a difference of squares. We fill the front with the x's. We get 1 positive and 1 negative, and we fill the back with what we square to get the 49, which is 7. Before moving on, we're going to look at our denominators and state our restrictions. So our restrictions are -2 from the first 2 x plus 2's, and then positive and -7 will give us 0 in the denominator. And then we're going to go ahead and cancel. And we're left with x plus 4 over, or sorry, x minus 4 over x plus 2.